Hello friends, Namaste. Welcome all of you to my channel. Today let's discuss about the modern portfolio theory developed by the Markowitz in 1952, which is also known as the mean variance portfolio theory, which is under the concept of risks and returns. How we could minimize the risks and maximize the return, I mean to say that. Normally we say that no risk, no gain. But the important point is that to what extent we could take the risks and maximize, or you can say that optimize our returns. So for that reasons, the portfolio theory is very important, friends. So based on this background, now let's talk about what we are going to discuss today. So this is all about the background which I just discussed. Then we will discuss about the portfolio risks and returns, illustrating the concept, portfolio of the two risky assets, and portfolio of the treasury bill, T bills, that is the and the risky assets. One is the risk free and the risky assets. And finally I will discuss about the minimum variance portfolio, friends. So let's talk about first of all what about the risk and return. When we say that as per the Pandey, that's I am Pandey 2006, the risks and returns are the most important concept in finance, no doubt. And in fact, they are the foundation for the modern finance theory. So it's very important is that a risk return trade-off, which is related to the preference of the investors, and particularly when we say that rate of returns, which consist of mainly dividend yield and the capital gain yield. Okay, so dividend yield is here, that's a ending price, yeah, pt, you can say that, divided by pt minus 1, while capital gain means pt minus 1 divided by pt minus 1. That means there might be the returns. Simply you need to understand here that the return could be positive or negative, and simply return could be measured as a arithmetic average, yeah, geometric average. You can see this is the geometric mean return. So this is the 1 plus r1, 1 plus r2 up to 1 plus rn whole to the power 1 by n minus n, friends. Okay, now um, when we talk about the what are the three statistical methods which are commonly used to measure the risks. So this is the standard deviation, variance, and the coefficient of variations. So one of the contributions made by the Markowitz, which discuss about the quant revolutions, stated in the Wall Street in 1952, and that's under the seminal paper Portfolio Selections, which published in the Journal of Finance, and which are the applied mathematical concept to finance. We say that. So it's all about modern portfolio theory, which shows the that using the principle of expected variance, it is possible to hedge the risks posed by the individual stocks by selecting the stock with minimized risks. That's stated by the Markowitz. So now let's talk about, let's illustrate the concept of portfolio risk and return, and consider the two example here. The investment problem, we can invest two non-dividend paying stocks. One is the Amazon, which is noted by A, and the Boeing B over the next month. Now let assume that RA denotes the monthly simple return for Amazon, and RB denotes the monthly simple return of a stock of Boeing. So I mean to say that, friends, we assume that, yeah, that's the returns both companies are jointly normally distributed. Okay, because while using the any statistical application, we assume that data are normally distributed. Okay, and that's why following the informations about the mean, variance, and covariance of the probability distribution to returns, we have like a mu a, that's simply expected return of the RA, and the next one is, this is the notation for the variance. Okay, and the mu b, this is the ERB, we can say that, and this is the simply we see that covariance of AB, that's we have a return on A and the return B. So this is simply we can say that covariance of RA RB, and this is how we could find it. And this is the we say that yeah, correlations coefficient. Okay, this notation is the coalition coefficient, which is simply covariance divided by sigma A and the sigma B. That means when you are using the concept, you have to understand the first of all its mathematical equations. Okay, but the important point is that the realized return may not be may be different from our expectations. So R may not be equals to the AR. That is the reality, and we can think that variance are the measures of the risks associated with the investment, and asset with the high variability or the volatility we see that risky, while asset with the low return volatility are often thought to be safe and gives us the information about the directions of the linear independence between the returns. Okay, now let's talk about what about the portfolio risks and returns. And simply a strength of dependence between the returns is measured by the coalition coefficients. Okay, and for populations this is the notations, and for sample we see that R we can use it, which values lies between the -1 +1. And here the asset A is the high risk assets, and annual return with mu A is the 17.5% is given, while annual standard deviation sigma A is 25.8, while standard deviation B is the low risk, and that's why the mu B is the we have a 5.5 percentage, while the standard deviation is 11.5 percentage. So assets are assumed to be slightly negatively correlated with the correlation coefficient we are given, that's the minus 0.164. Now how we could find the covariance of return, friends? So covariance, simply we simply organize the information. Covariance is that correlation coefficient into sigma A and the sigma B. So we can use the yeah, this is the we have how much we have 0.164. So this is the 0.164, and the next one is we say that uh, this is the 0.258 is the sigma A, and the sigma B is the 0.115. So this is our the covariance. So simply we can say that while analyzing the results, if our covariance is greater than 0, then we say that two returns tend to move in the same direction. But at the same time, when the covariance is lower than 0, that in this case, then returns tend to move in the opposite directions if we have a negative value. At the same time, when the covariance equals to 0, then returns tend to move independently, we say that. Okay. Now let's talk about what about the portfolio of the two risky assets. So simply you need to understand here the proportion of investment in the A and the B can be positive or negative. So positive value denote the long positions, that is a purchase in the assets, and the negative value denote the short position, we say that sells. But point is that this proportion of A and the proportion of B investment must be 1. Okay. So that means when you are asked to find the expected portfolio return, so simply we say that we can write ERP, or simply R bar P is that proportion of investment in A, then ERA we can say that, or proportion of investment in the B, and this is the ARB. Okay. So that means that's a mu P and ERP is this is the same I just discuss here, while variance of the portfolio case is that proportion of investment in A square, variance of A, proportion of investment of B square into variance of B, and the 2, and that is proportion of investment in A into proportion of investment in the B, and the covariance, friends. Okay. So that means simply we have to understand the things from the your how we could decide about, yeah, that's the proportion of investment in the A and the B. That it depends on your risk taking behavior. Okay. Now what about the case of the portfolio of the two risky assets and the portfolio of the treasury bill and the risky assets? So let's assume that our proportion of investment in A and the B both are the equal. So 0.5 in the A and 0.5 in the B. So in this case, we could find the ERP that simply as I discussed earlier, this is the 0.5, 17 point, this is the 50, okay. 17.50 is this one, I mean to say that, okay, 17.5, okay. Then what about the case of 0.5, and this is 5.5. 5.5 is that this is the case. 5.5 percentage is that this is okay. This is the given. Now, similarly, standard deviation of the p, this is the square root of all this value. Simply we put the values all here. So your value would be 0.1323. So at the same time, when we consider the short portfolio, if we have a that's a proportion of investment in the A is 1.5, so that means proportion of investment in the B would be the minus 0.5. So condition is that proportion of investment in the A plus proportion of investment in the B must be 1. Okay. At the same time, there might be the situations we say that portfolio of the two risky assets, if the portfolio of the treasury bill and the risky, so one is the risk free and the next one is the risky assets. Simply you have to understand here that is friends, risk free assets of the security has a zero variance or standard deviation, since risk free security has no default risks. Like one of the example is the government treasury bill, bonds are the appropriate example of the risk free security which has a no default risk. So okay, while the covariance and the coalition coefficient of the risk free assets with any other portfolio of the risky asset is also zero, but it doesn't mean that portfolio of the risk free and the risky assets a risk free is, that means not necessarily a risk free portfolio. Okay, that would be minimum simply. Now, what about the case of minimum variance portfolio, friends? So, minimum variance portfolio is the one of the contribution of the Markowitz, which discuss about the minimum variance portfolio with the lowest level of risks in the efficient frontier. Okay, in efficient frontier, in coming days, I will discuss about how we could draw the efficient frontier using the Excel tool. But anyway, in efficient frontier, simply in x-axis we have a standard deviation of the p, and y-axis we have a expected return, we say that. So it is also called the risk minimizing weight or the optimal weight. However, investors don't like necessarily strive for a minimum variance portfolio. As for example, the risk averse investor will have a trade-off between the risk and return. So that means investor choice of a particular portfolio will depend on the risks, on their risk preference. Okay. So simply proportion of investment in the A, if this is not given in the questions. So this is the variance of the B minus covariance of AB whole divided by variance of A plus variance of B minus 2 covariance AB. Okay. Simply I put the form given equations. Okay. And I came to know that yeah, that's a 0.20, that's a 20% in the A, and that's why this is the 1 minus 0.2 is the 80% would be in the B, and this is the optimal weight which could minimize our portfolio risk, friends. Okay, I hope that whatever I discussed today, overall risk minimizing portfolio concept, modern portfolio theory, it will at least clarify about the concept of overall risk and return principle, we can say that. If you really like this content, please like, subscribe, and don't forget to share my channel, that is the finance guru Pawan Kumar Jha. Thank you all of you for watching this video. Please take care all of you. Thank you.